Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The reaction of alcohols with HBr proceeds via protonation of the OH group followed by departure of water to form a carbocation, which then reacts with Br. The rate of this reaction depends on the stability of the carbocation intermediate formed after protonation and loss of water. Moving on to the next step. Identify the type of alcohol in each option. A. Secondary alcohol on a bicyclic, cyclopentane cyclohexane fused system forms a secondary carbocation. B. Tertiary alcohol on a bicyclic, cyclopentane cyclohexane fused system. The carbon bearing OH also has a CH3 group and is at the ring junction, making it a tertiary carbon, forms a tertiary carbocation. C. Secondary alcohol on a methylcyclohexane ring, trans 4-methylcyclohexane 1 old type, forms a secondary carbocation. D. Secondary alcohol on a methylcyclohexane ring forms a secondary carbocation. Moving on to the next step. Alcohols react with HBr faster when they can form more stable carbocations. The order of carbocation stability is tertiary, secondary, primary. Therefore, tertiary alcohols react fastest with HBr. And for the final step, option B has both OH and CH3 attached to the same carbon at the ring junction of the bicyclic system, making it a tertiary alcohol. Upon protonation and loss of water, it forms a tertiary carbocation, which is the most stable among the four options. A. Secondary alcohol slower than tertiary. C. Secondary alcohol on methylcyclohexane slower than tertiary. D. Secondary alcohol on methylcyclohexane slower than tertiary. Option B forms the most stable, tertiary, carbocation intermediate, so it reacts with HBr at the fastest rate. Therefore, the correct answer is B. Therefore, the correct answer is option B.